All right. So we're here um, to start the broadcast. Looks like everything is ready to go. Let's get started. So today I wanted to start the gendered pronoun competition on resolution competition on Kaggle. And I haven't looked at it really. I'm familiar with it, but I haven't looked at it in detail. And I want to get started and get its submission. So today I wanted to review the competition, explore the data set, explore the example submission, and then the first idea that I have to give a submission is to find a way to use BERT. BERT is like a new language model that was created by Google AI, and I've been really obsessed with it. So I want to find a way to use it and actually make a submission. So let's go ahead and check out the competition. I've already accepted the terms and conditions. So let's go. Let's see what this overview says. Can you help end gender bias in pronoun resolution? Pronoun resolution is part of a co-reference resolution, the task of pairing an expression to its referring entity. This is an important task for natural language understanding, and the resolution of ambiguous pronouns is a long-standing challenge. So Lucy went to the gym, and the second sentence is she was happy. And in this sentence pair, she, the pronoun she, refers to the word noun Lucy. Second sentence, Lucy went to the gym. Her dog stayed home, where her refers to Lucy. So when pronouns refer to nouns, that's pronoun resolution. And this is a part of co-reference resolution where it's what pronouns or what other words are referencing nouns in sentences. Or other nouns refer to other nouns as well. Unfortunately, recent studies have suggested gender bias among state-of-the-art co-reference resolvers. Google AI Language aims to improve gender fairness in modeling by releasing the gendered ambiguous pronoun dataset containing gender-balanced pronouns, 50% of his examples containing feminine pronouns and 50% containing masculine pronouns. So this study says that there's a gender bias among state-of-the-art co-reference resolvers. That's probably due to the data that they're trained on, where more than 50% is going to a particular kind of pronoun, probably masculine if I were to guess. So this data set aims to combat that by creating a data set where there are equal examples of feminine and male pronouns. In this two-stage competition, Kagglers are challenged to build pronoun resolution systems that perform equally well regardless of pronoun gender. Stage 2's final evaluation will use a new dataset following the same format to encourage gender-fair modeling. The ratio of masculine and feminine examples in the official test data will not be known ahead of time. So the first part is just to qualify for the second part, and we're not aware of the test data's ratio of masculine to feminine examples. So you can't game the system. You can't game the scoring by knowing the target ratio. Anyway, so evaluation using multi-class logarithmic loss. Each pronoun has to be labeled with either A, B, or neither. That makes this a multi-class problem. For each pronoun, you must submit a set of predicted probabilities, one for each class. Oh, interesting. So the log loss is equal to the negative times 1 over n. So that's sort of like the average, right? Because n is the number of samples in the test set. M is 3, which has to do with the multi-class number of labels. Log is the natural logarithm. Yij is 1. If observation I belongs to class J and P otherwise. And Pij is the predicted probability that observation I belongs to class J. So if your probability for that observation and that class matches up, then it's 0, right? The difference 1 minus 1 will be 0. And when they don't match, then that's how you get a positive number, and that's why it's bad. So you want to make that number as small as possible so you can maximize your log loss. Submitted probabilities are not required to sum to 1 because they are rescaled prior to being scored. Ooh, interesting. Each row is divided by the row sum. In order to avoid the extremes of the log function, the predicted probabilities are replaced with max, min. So this is so you don't have any like divide by 0 issues. And then here we have a submission file where you have the ID, A, B, and neither. The order of the rows does not matter. The file must have a header and look something like the following. All right, timeline. Today is February 23rd. All right, let's get started. And then prizes. Cool. So let's look at so we were able to review the competition. Sweet. Now let's explore some data. In this competition, right, you must identify the target or the pronoun within the text passage. The source test is taken from the Wikipedia articles. You're provided with the pronoun and 2 candidate names to which the pronoun can refer. You must create an algorithm capable of deciding whether the pronoun refers to the name A, B, or neither. Unlike many Kaggle challenges, this competition does not provide an explicit labeled training set. Does not provide an explicit labeled training set. Files are also available on the GAP dataset GitHub repo. Note that the labels for the test set are available on this page. However, your final scoring ranking will be determined in stage 2 against the withheld private test set. All right, so the test set data for stage 1, okay, and then a file showing the correct submission format for stage 1. So those are the 2 data files, test data, and a sample submission file. So we're going to focus on the data file first. The columns are unique identifier of the example, the text containing the ambiguous pronoun, and 2 candidate names, about a paragraph in length. So a lot of sentences, multiple sentences is the issue here. Pronoun, the target pronoun, the character offset of the pronoun in this text for that unique identifier for that observation. The column A, the first name candidate, the offset of the name A in text. B, second character, second name candidate, the character offset of B in text. URL, the source of the Wikipedia page for this example. All right, so what does this look like? 2,000 examples. All right, so probably the 2,000 examples. Interesting, one of the 2,000, hence 2,000 unique values for the ID. That makes sense. 1,199 unique values for text. So that means one of the texts are actually reused. 27% of the pronouns are her. 25% of the pronouns are his. And there's 7 other pronouns. What are the other pronouns? Contains. Is there an easy way to find what the other pronouns are? Oh, interesting. Capital versions. Is. We can use pandas or something to figure out what the exact values are. All right. So then you have the pronoun offsets. Most of the pronouns are 1,000 characters into the text. Oh, no. most of the pronouns are 229 to 342 characters into the text. All right. So the A, 1,743 unique values. So this is the A candidate, and those pronouns are usually, these candidate nouns are usually before the candidate pronoun or before the pronoun, right? 194 is less than 229. Interesting. Then you have the B candidate, 1,774 unique values. Cool. And then these B offsets on average are actually after, right? 232 is greater than 229. It's usually after the pronoun. Interesting. So you have a before and after. And then these unique values are the actual article. All right, cool. So yeah, so that's the data. Interesting, interesting, interesting. More data. All right, now time to explore the example submission. Should be very quick, right? So for each of the development IDs, you have your A column, B column, and neither column. And you have the put a probability. They don't have the sum to 1, and they'll automatically be added and they'll be scaled and normalized so that they do add a 1 on their side for scoring purposes. All right, example submission. All right, so find a way to use BERT. All right, so let's see if any of the other kernels have used BERT. No, none of the kernels have used BERT. Interesting. And this is there. I want to, so tag in kernels. Yeah, so I want an example of how to use the BERT model in a kernel. Introducing BERT with TensorFlow. Let's search kernels. BERT. Data preparation and exploration. So yeah, so let me back up a little bit. So the BERT is a language model built in TensorFlow by Google AI. And when it was initially released, it beat a lot of, state of the art competitions and like question answering and entity recognition. So I'm really into, I don't know if it's going to work, but I just want to try and see if I can get BERT to work for this competition. So we have to figure out a way to specify the BERT model so that it will like answer our problem, fix our, solve our problem. So let's see the kinds of ways that BERT is used. So there's sentence and sentence pair classification tasks. So that's not going to help. This is where co-reference resolution is not a classification task, or not readily a classification task. Question answering data set. Maybe we can pose BERT as a question answer. This isn't really helping me. I think it would probably be better if I actually look at the paper. All right. If you're interested to learn more about the BERT in detail, there's actually another Kaggle There's a Kaggle reading group where they actually talk about bidirectional encoder representations. So if you go ahead and click on this.
All right. Good morning. I'm going.
Yeah, so this is Rachel. Rachel talks about the actual BERT paper. Oh no, not the BERT. This isn't the BERT paper. This is the transform. Oh, it is BERT. Yeah. So if you want to know details, specific details about everything about BERT, going over the paper, I really suggest that you go over that playlist. But we are going to try to figure out how BERT was used. So next sentence prediction. So trying to predict the next sentence based on the current sentence? No. Those are comparisons. So MNLI, QP. All right, cool. So here are different BERT architectures. So you have a single sentence classification task. No, that doesn't work for us. Sequence sentence pair classification task. No, that's not going to work. Question answering task. And then single sentence tagging tasks. So the interesting thing there is to create. So if we look at tagging maybe. The issue with tagging is that in order to create the issue I have with this is that we don't know. So single sentence tagging task. So this is entity recognition, the Kana now. Right, named entity recognition. Is that? So you in order for that to work, you would actually need to fine tune BERT. You would need a specified token for each. You would need a output. You would need a labeled, output for each token in your output from your input, right? So each of your n tokens has a specified tag. So that's not going to work. I really wonder if we can pose it as a question answering task. So like, I wonder if we can say gendered competitions. We need to go back to the competitions. If we say, given this sentence, so how does BERT work? So they do question, paragraph, that's the input. You do regular tokenization, and then the output is after the separator token, you get a start and end span. So let's see what that looks like in Squad. Right, so input question, where do water droplets collide with ice crystals to form precipitation? Input paragraph, precipitation forms as a smaller droplets coalesce via collision with other raindrops or ice crystals within a cloud. So the interesting thing, and then the output answer is within a cloud. So within a cloud is output directly by BERT. So we could try to pose the question as, if we say, the question is like, which noun does she refer to? And then, Lucy went to the gym. She was happy. And then I would say, and then Lucy, because I would, and I like that because even though this is really crazy to see if this works, because this would miss the least amount of like pre-processing. We already have the labels. It's a really nice way to, to pose and fits nicely within BERT. So, all right. So now that we have a path, ID number 1, find a way to use BERT. All right. So news view. Use BERT. Like squad. go ahead and move that up. All right, cool. So now we know we want to do it like squad. So now we need to incorporate PERT into a Kaggle kernel. Oh, the guy's name is BERT. That's why this came up. Yikes. Yikes, 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 yikes. All right, I want BERT in kernels. Kernels. Let's see if we can find a BERT kernel. So we did all the heavy lifting for us. Introducing, I like sorting my kernels by most votes because I believe in the BERT NLP with base implementation. The wisdom of the crowd is what it's called when you use. Oh no, it's this one is what I wanted. And we are in kernels. I wonder why. All right, so cool. Deep learning with sentiment analysis. BERT here. So this is because the guy's name is BERT. All right. Introducing BERT with TensorFlow. What is this guy doing? BERT is a method of tensor pre-training. So this is all based off of a Colab notebook. Yeah, he's downloading a model, importing libraries, opening the downloaded file, checking it, getting some needed file. So he's actually getting it from the Google research BERT. I wonder, so it looks like, is there a squad? Oh, sweet. So there is a run squad. All right. So instead of run classifier, we're going to use run squad. All right. Similar to Cola. The Cola is not what we care about. But he has a training set, train test split, create examples, batch, run, creates a model, ignoring params for now. This is a lot of code. Does it really need that much code? Train for BERT at this moment. Our result will fine-tune a single cloud TPU, which has 64 gigabytes of RAM. Most of the BERT large results on the paper are using a GPU with 12 to 16 gigabytes of RAM. Because of the metro max size, that can fit in memory is too small. Competition test. I've run a test with 30% accurate data on free Colab TPU and achieved F1 score of 68%, 11th place at the moment. You can't use BERT in the competition, and notebook will fail when it comes to real testing. I apologize for literally what I couldn't believe. That local test was so high, so I had to check. Train took 30 to 40 minutes. Results are really amazing, especially because it's a raw model and ran a 30% sample with no optimization or ensemble, using the simplest of 3 released models. Model does it for you, right? It's because it's all in the tokenization files, pre-processing. All right. So this is a very promising notebook. So this is BERT NLP, and this guy has a lot of, I don't know, looks like a lot of street cred. So I think I'm gonna check out what he's up to. Looks like what this guy's doing really is just explaining the model. Just remove the PyTorch implementation here. I've commented all the code, path, other issues. Try this code, it works perfectly. Oh, it's all in. I don't know if I want to go with PyTorch demonstration of BERT model. Poor reproducibility, 50,000 to build this model. All right, so this isn't it. I can't use that. Can we fine-tune BERT from Apache MXNet using MXNet and Glue on NLP? Not sure if I want to follow this MXNet stuff. That seems, yeah, this guy is doing way too much. Skip. Data preparation and exploration. There's nothing here about BERT. All right. Winner, winner, chicken dinner. Let's go ahead and fork this. Go ahead and fork this. You agree to the following competition rules. I understand and accept. So looks like you can't copy kernels between competitions. Very interesting. Or I guess it doesn't make sense that you would want to copy one kernel from one competition to another competition, but I want to do that. So if I can download this kernel, oh, I can share. Here, cancel, stop. If I make this public, yeah, make public. Your kernel is now public. Oh, I have to commit before I save. So commit. The committing runs for your work. Return to editor. Oh, it's running because I committed the code. I wonder if there's a way to export this kernel. Console. And kernel. Save your data frame. Submitting from a kernel. Kaggle API. I want to download kernel. Yeah, is this possible? Download a kernel as a Jupyter notebook. I want to download it with the output under each cell. Example. Enter the code with the option to edit. The right corner is a cloud with a down arrow. Oh, that makes total sense. Download. I'll make sure to give this guy his props. I'll save this for later. Love getting credit. Haven't. Wait, we didn't make submission. guess I can go ahead and delete one. All right. So now that I have that downloaded there, I can create a new kernel notebook. Because we're going to upload a Jupyter notebook. We're going to go ahead and upload a kernel. Sweet title for your notebook. Introducing BERT with TensorFlow. Where is this game? Fork from. Right. Oh, cannot exceed 50 characters. How about credit? Forked. Good. Goodness gracious. Oh. With BERT squad. Forked from. Man, I'm really into giving people credit. Yes. Right. So let's go ahead and commit. Oh, I need to make this accessible from the internet so that I can download stuff. Confirm. Or else that's why probably why this one failed when I cloned it, because the internet, it wasn't connected to the internet. All right, so let's get familiar with this squad stuff. Oh, actually, so we should keep that other one open, the original one open. I really hate waiting. So my idea now is, so given this working example, instead of using classifier, we're going to use squad. All right. So I was using BERT. Right. Yep. We're going to see what's inside. And instead of classifier, we're going to do squad. Yep. Sweet. Similar to squad. Oh my goodness. Too many words. Looks like I can still use what he's doing. All right, so instead of train CSV, it's test stage 1 TSV. Test stage 1 TSV. So here he's doing test size of 10%. I think I'm going to do a test size of 30%. Okay. So this isn't going to work, right? Because let's go ahead and add a code block above. Instead of regular CSV, separator is tabs. What does that look like? All right, sweet. So that's that. Train DF. So after train df. All right, so we have the right file name. I split it up. So test train. So now, ooh, see, this isn't gonna work. Maybe it will. Oh, they don't have the answer. We don't know if it's A or B or neither. All right, let's see how squad works because I don't know how they format their input. Let's open the previous QUAD. Squad. All right, squad. I want to know what this data looks like. It's going to be a huge file. What's going to be really small is this dev file, or it should be small. Dev's usually smaller than train. All right. Title Super Bowl. This is not looking good. So, extension JSON. Yeah. Pro tip, you want to look at well-formatted JSON, you're going to want to download JSON view. So when I refresh, ooh, the state-of-the-art squad results cannot be reproduced on a 12 to 16 gigabyte GPU. A reasonably strong BERT base can be trained on the GPU with these hyperparameters. All right. Must be a big file. Having trouble parse it. I just want to know really quickly how the input and output were specified. Okay, cool. So you have the context, question, and then an answer. 177. So, oh my goodness, I lost what I was doing. Oh, I want to see how. So I bet you. Let's see how in Run Squad they use context. Context. Oh, here you go. Paragraphs. All right, so this is going through the JSON file. Context. Yeah, for each entry in data output. For each entry, you're going to go for each paragraph, right? So for each paragraph, yeah, list of paragraphs. Each paragraph has a context. Each context has a list of questions. And then the questions. And then what about the answer? So yeah, if training is impossible, if not impossible. So is impossible as if there's no answer. Yeah. And if not is impossible. So is possible, then you actually have your answer. And how does that all? Well, my question is, how is that actually all like put together? So your squad example. So this is the innermost loop. Right, so for each question, you have a squad example. Oh, so this is what you want to create, the squad example. The question ID, the question text, document tokens. How do you create that? Doc tokens. Doc tokens, doc tokens. What happened? Oh, here you go. In the paragraph text is white space. Oh, this is iterating over the characters. Yikes. Doc tokens, original answer text, right? So trying to figure out how the squad exam was put together. So answer text. Answer text. Sounds good. Ooh, start position. End position is impossible. So start position, chart a word offset, answer offset. Answer offset. Answer offset is from answer start. Great. But then the answer end position is the offset plus the answer length minus 1. The character to word offset. Yikes, what is that? I feel like this just needs to be executed in order to actually figure out how squad is working. And that's all because, oh, I can just, for paragraph. So yeah, I can just execute this in a cell. The best way to figure out how something works is to execute it. So these are all else in chart offset or oh, it doesn't like the 2-character indentation. That's why it's copy paste. Barrels of copy paste. So everything's the same up until the 4, correct? Indent if prev else, indent in out, in out, in out, and then the chart a word offset. This is the same level of else. This else. All right, cool. So let's check what happens if the paragraph context. Ooh, an error has occurred with the running of the script. Oh, probably because script's not going to work because this logic doesn't make sense here. Question text doesn't exist anymore. Target doesn't exist anymore because we changed our input data. Oh my goodness. Save though. Is committed. Okay, good. Train DF. First row. That like loc 0. Loc 0 dot. An object of capital text. And so this is our example paragraph context. This white space is not defined. Touche. That is white space. Perfect. Yeah. Stupid formatting. All right, that seemed to have worked. What does char word offset look like? Good luck. Char to word offset. Okay, so each character and then the word that that character corresponds to, right? So if we compare that with, so if we move this down, how do you move it down? Can't seem to move it down, but we can just copy paste it. All right. So 1, 2, 3, 4. 1, 2, 3, 4. All right. Telford. Oh, interesting. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh no, it did. So it's broken up based on spacing. And that's it all the way down. All right, cool. So now if we go back to BERT squad, character to word offset. Oh, so this is the position is the word. The start position is the word. And the end position is the word number. Interesting. And then is impossible. If QA is impossible. If we go back to the data, what are we? Notes. So Preposition slash word position. Word number. Yeah. Those are all self-explanatory except dollar. See, you take notes because I don't even know what doc tokens are. All right. Oh, doc tokens are literally just the doc tokens. So if we were to do doc tokens, oh wow. Doc tokens are the actual words. Doc tokens are the actual words from the paragraph. Where am I taking notes? And Google Keep. All right. The array of words. It is impossible. That's the only one that doesn't really make sense. Question is impossible. Question. If you're called is impossible. JSON view. If I want to like view page source. The bad thing about JSON view is that you can't really search. Can't really search the text easily. Oh, maybe you can because this isn't coming back with anything either. Huh. So I don't know where this is impossible is coming from. Oh, version 2 with negative. So one thing that's crazy is that this data set doesn't have the answer. They're actually forcing you to go to their, they're actually forcing you to go to that GPU site. Gendered pronoun resolution. Oh, the gap data set, that's what it was called. Yeah. Ambiguous pronoun. So let's see if we do gap test. Ooh, megabyte. View it raw. So pronoun A offset. A co-reference. Oh, the answer is here. Let's see where Zoe is. Because this is called test stage 1. So is Zoe Telford in this data set? No, it is not. Very interesting. So when they say test, do they mean dev? Yes, they do. Oh, development. Ha ha ha. Oh, they don't have the answer here in the development data set. Oh, yes, they do. Right there, a co-reference. True, false. Hmm. So we should actually get this file. I wonder if we could put it, oh, read only in the input folder. All right, so we'll just get it. So we want another cell, and we'll just use their get raw input. Yeah, here we go. Char, so you get, and then this exclamation point is called like bang. That's how you execute the command line. That's how you get command line inputs. So if we were now to do gap development suite, right? True and false. So that's how we're gonna get our answers. An hour is not enough time. We barely got anything. My question is though, how many examples are here? 2,000. Sweet. Let me just commit this. All right, committed. So we didn't get any more training data, but this is how we have the answers, is by actually using the GitHub repo data. All right, so we don't need this anymore since we know what this is doing. Don't need that anymore since we know what that is doing. So a little bit, so we should actually have the parts of the squad labels as our input. So we have, what are these column names? Columns. So we'll have train ID need. For each example. You need an ID. You need the train question. Ooh, very interesting. Not train question. For each train. So it looks like we're gonna have to process this train DF before the train test split to create these other. Okay. We already have ID, so we need to add. So what we're gonna do next time, add tokens. Give the add word number of answer. And the end word number text. And then that is possible. Oh, so that'll be easy. So if they're both false, if both A co-ref and B co-ref false. So train DF. So it's impossible if they both are false. So you say not and so now this is like the data munging part. Valid syntax. Column. Oh. A condition. No, I don't like that. A new Boolean column. Yeah. Oh, so I just need some. So it's a bit operator and some parentheses. Oh, so I need this bit operator and oh, bang doesn't exist. Maybe it's a is it this? Yeah. Key reference. Wait a second. Delete this. Use this. False. So false and false is true. Alrighty then. False and false is true. Otherwise is impossible. All right, cool. So the rest of this requires direct references to the squad example. How long have we been going? Live events, 11:22. A little bit over an hour. All right. So I just wanted to do an hour every day. We didn't even get half as much as I wanted to do. So let's go back to squad. We need to add squad example attributes to train data. We need to do that to use BERT like squad before we make our submission. All right, we did the credit thing. Gave the man credit. All right, well, thanks for following along. Till next time. Actually, it didn't turn off the broadcast because I'm a total noob when it comes to this broadcasting stuff. How about this weather?